In this lesson, we are going to talk about elemental analysis. The goal of elemental analysis is to determine what is known as the empirical formula of a compound. Now, the empirical formula of a compound is a formula where the subscripts reflect the relative number of atoms of each element in the simplest possible terms. So, for example, glucose has a formula of C6H12O6. Okay? The carbon to hydrogen to oxygen ratio is 6 is to 12 is to 6. Now, you can see that 6, 12, and 6 have a common factor. So, you have to reduce that ratio into the smallest possible set of whole numbers. And a good strategy for doing this is just to divide everything by 6, the smallest number. So you'll have 6 divided by 6 is 1, 12 divided by 6 is 2, and 6 divided by 6 is 1. So you can say that the carbon to hydrogen to oxygen ratio in glucose is 1 is to 2 is to 1. So CH2O would be the empirical formula of C6H12O6. So how can you tell that you have the smallest possible set of whole numbers in your in your formula? In other words, how can you tell that what you have is already an empirical formula? The way to tell is this. If the smallest of all the whole number subscripts that you have written is 1, then that means you've already got the simplest possible formula. Now, if all the subscripts are divided, but if that's not the case, then what you do is you divide all the subscripts by the smallest, and if one of the results happens to be not a whole number, then you already had the smallest possible set of subscripts. Okay, so for example, let's look at C3H6O2. So that's 3 is to 6 is to 2. Okay, that's the ratio of the subscripts. So the smallest is not 1, so you need to check if these are the smallest possible subscripts. So you divide by the smallest of these, which is 2, so you divide by 2. 3 divided by 2 is 1.5, 6 divided by 2 is 3, 2 divided by 2 is 1. And you can see that this is not a whole number, so that means this is already as simple as it gets. So C3H6O2 would be considered an empirical formula.